Well done Year 9 and all your hard work so far in our radioactivity topic. Today we're going to look at background radiation. We're going to be able to list sources of background radiation and describe the difference between two really important keywords, contamination and irradiation. You will need to define what we mean by background radiation, describe where background radiation comes from, and explain why different levels of radiation are present in different areas around Britain. All of these items here emit some source of radiation. When we looked at what makes something radioactive, we looked at the idea that these atoms have an unstable nucleus and try to become stable by emitting an alpha, a beta or a gamma particle. All of these materials here will do that in some form, but don't worry, there are different amounts of radioactivity. This lesson is going to focus around this 6-mark question. 6-mark questions are quite common in this topic during the exam because there's lots of information that you can learn to share with the examiner. The question, explain what is meant by background radiation and why it's different in different parts of Britain. And you can see that that matches perfectly with the success criteria that we had for this lesson. You also need to remember that when we're answering 6-mark questions, we need to look carefully at what the command word is. Now the command word for this question is explain. This shows the mark scheme for the word explain and how an examiner would mark your work. You would get somewhere between 1 and 6 marks. For 1 to 2 marks, you have to clearly identify, but simply, your point. For 3 to 4 marks, you have to make relevant points. You've got to identify these points, but it doesn't matter if they're not fully linked together. For 5 to 6 points, you need to make sure you make relevant points and you detail them in a logical way to form a clear account that clearly answers the question. So we need to look at what background radiation is and where it comes from. When we looked at alpha, beta and gamma radiation, we said that all of these forms of radiation are ionizing, meaning they can potentially damage cells due to the high amounts of energy that they contain. So background radiation is a potential danger if it's all around us and occurring in naturally and man-made sources. But there is a safe limit of radiation that the body can be exposed to. And we measure this radiation using something called a Geiger-Müller tube. And we measure it in becquerels or counts per minute using this instrument. All of the things that emit background radiation fall within a safe dose level, which means that they will not cause any potential harm to the human body. Background radiation is all around us. We are constantly bombarded by radiation from lots of different sources. But as we said previously, it's at a small enough level that we are safe. As we know from our chemistry topics, carbon is present in our atmosphere and in our plants and in the soil. This means that radiation can be present everywhere throughout the food chain. We find radioactive materials in plants and animals. It's emitted from the sun and found generally in space. Building materials and rocks are a large source of radiation in our environment. Radiation is also found in hospitals and nuclear power stations. But as we said before, radiation levels around our background that we are exposed to on a daily level are not dangerous. It's not something that we need to be concerned about. The average radiation dose is 2.4 millisieverts per year, and the milli tells us it's a really small number. Sieverts being a new unit that we can measure radiation in. So don't worry, nobody is at risk from any radiation source in our environment. When we look at background radiation, we can break it down into the sources to see how much we are exposed to from lots of different places. 50%, half our exposure, comes from something called radon gas, which we'll look at in a little minute. We then have 4 similar size areas, which are food, cosmic rays, gamma rays, and medical sources, and they contribute to almost the additional 50%. The final slots come from nuclear power, so you can see that there is only a small proportion of radiation that we are exposed to that it comes from man-made materials. If 50% of our background radiation comes from radon, we need to know what it is. Radon is a gas that is found naturally in rocks. Granite rock emits radon gas, which is found in the bedrock, the rocks and soil beneath our feet. It's not a particular danger in the environment, but potentially could be in enclosed spaces or if you breathe it in. If you look at the map on the right, we can see areas of the country where there are higher and lower levels of radon gas in the bedrock. None of these are to a level that would be above the safe levels of background radiation. The particular risk from radon comes from emitting alpha. We know from our prior learning about the 3 types of radioactive decay that alpha radiation is the most ionizing of our 3 types. It's made of 2 protons and 2 neutrons, and therefore can cause the most damage to human cells. However, we know alpha radiation is the least penetrating, and therefore very easy to protect yourself, as it can't travel into your body through the skin, it can't travel through paper, and it certainly can't travel through the materials that make up your house. Exposure to the source, if it's outside the body, introduces the first of our 2 key words. It introduces the idea of irradiation. You are irradiated if you are in the same environment as a radioactive material. It is when the exposure is outside of the human body and the radiation is travelling in that environment around you. We are irradiated a lot of the time by our background radiation. Our second key word is less likely, and it's contamination. If radiation gets inside your body, we call it contamination. The levels of risk from irradiation and contamination vary depending on which type of radioactive decay we are talking about. We now move on to our 6-mark question to explain what is meant by background radiation and why it's different in different parts of Britain. This is what we call an extended response, and if it's 6 marks, we're looking for 3 main points that we make. Our success criteria from today's lesson is broken down into 3 areas. Therefore, for the full 6 marks, we need a sentence or detail about each one of the 3 points. We need to define what we mean by background radiation. We need to describe where background radiation comes from, and we need to explain why levels of background radiation are different in different parts of Britain. Stop the recording now and give yourself 6 to 8 minutes to have a go at answering this. Now you've had a go at answering it, you can mark your work. The first 2 marks come from the first couple of sentences in our model answer. It tells us what background radiation is and how we measure it. It gives us a little bit of extra detail about what it includes. So for the first 2 marks, we have background radiation is the radiation that is all around us all the time at a safe level. It's measured in becquerels or counts per minute. It includes alpha, beta and gamma. There's our first 2 marks. The second 2 marks is to give some sources of background radiation. The first mark comes from mentioning radon gas. As 50% of our emission comes from radon gas, you need to make sure that you've mentioned it in your answer. Your next mark comes from stating a couple of the other sources. You don't need to include all of the ones that I have. So for your 3rd and 4th mark, these are the sentences. Most background radiation comes from radon gas, mark 3. Other sources include cosmic rays, food and drink, buildings, and the groups of artificial sources, medical and nuclear power, 4th mark. Our last 2 marks come from answering the final bit of the question to explain why the levels of radiation are different in different parts of the country. We finalise the answer here. The levels of radon gas depend on the bedrock, showing our understanding that we know bedrock means what the ground under our feet is made up of. And then it states some of the areas that were red on our graph from previously. Why don't you take a picture of your answer and how many marks you've given it? Your final task today is one of these three, and you can choose which one you want to do. Tell me how successful you were. Tell me what 3 things you've learned or what went well in this lesson. Is there anything else that you could have done to improve your work for today? Or you could choose to create an infographic, so a mind map or pictures or cartoons to explain what we did during today's lesson. Try to use images rather than words to help you get your point across. This makes it easier for your brain to remember too. Or you could write a summary of what you've learned. Can you do it in exactly 50 words to try and sum up all of the key points that we've done today? You can email me your response, or you can take a photo of it and upload it to ePraise. I'm really impressed, Year 9, with all the work that you've been doing. Well done, and keep it up.